Hi folks, Damon here. So it's been almost a year since we announced EMR Serverless at reInvent last year, and it's now generally available, and we've added a whole host of new functionality over the course of the past several months as well. So I wanted to give you an updated overview of EMR Serverless, how to run jobs in the console, how to run jobs via the CLI, and also how to use MWAA to go ahead and run orchestrated jobs using Apache Airflow. So let's go ahead and dive in. If you've used EMR before, you're familiar with the EMR console. With EMR Serverless, we use EMR Studio to manage your EMR jobs. If you haven't created an EMR Studio yet, when you go into EMR Serverless in the console here, there's a big, nice orange button there that says Manage Applications. And when you go and click that, we can create and launch an EMR Studio for you. So this goes ahead and creates an EMR Studio where you can manage your EMR applications. You can see I've already got an EMR application created, so let me go ahead and start that application. And we'll talk a little bit about pre-initialized capacity as well and how that works. All of the AWS resources that I am using in this demo are in a CDK stack in the EMR Serverless Samples GitHub repository. So in here, you see CDK, and there's this EMR Serverless with MWAA folder here. In here, there is a CDK stack that deploys EMR Serverless, MWAA, Amazon Managed Workflows for Apache Airflow, including some sample DAGs for Airflow. And I am also adding in a CloudWatch Dashboard. So you can see the stacks in here and all the different stacks that are part of this. So all the resources here, if you want to git clone the repository, do a CDK deploy, you can follow along in your own account. So let's go back to EMR Studio. You can see my application is starting there. If I want to create a new application with EMR Serverless, it's really easy. I just go ahead, click the Create Application button. I can just go ahead and name it my app, choose my platform that I want to use, either Spark or Hive, and my EMR release version. EMR releases, we try to keep up to date with open source releases, generally within about 60 days of open source release. So EMR 6.7.0 is Spark 3.2.1, I believe. And by the time this video is out, we'll have EMR 6.8.0 available in the console as well, and that's Spark 3.3. So we try to keep pretty recent with these. And then if I want to, I just click Create Application and I'm ready to go. But you can see here there's this pre-initialized capacity, and I want to talk about that really quickly. So with pre-initialized capacity, what that means is you can essentially create a warm pool for your EMR serverless application. And this means that your Spark drivers or Spark executors will be ready and waiting to run jobs instantaneously. With this configuration here, there's one Spark driver. So when you submit a job to EMR Serverless, that job will start running immediately. It will be able to use those two executors immediately as well. And then if it needs more capacity, it can use on-demand capacity in EMR Serverless. So we'll go ahead and add more and more capacity as your job requests it. We make use of dynamic resource allocation in Spark 3.x to request more resources as your job is running. We do have application limits, so you can't just request a whole bunch of stuff, and you can of course change these. The other thing about pre-initialized behavior, and let me actually go ahead in here and choose my custom settings so I can talk about this a little bit more. Under application behavior, we have the ability to automatically start or stop the application once it's idle. So if you want to have an application ready and waiting to receive jobs throughout the day, you can go ahead and do that. If nobody submits jobs within a certain amount of time, by default 15 minutes, we'll go ahead and stop that application so you're not getting charged for resources that you're not using. You can turn this off or back on. You can also have it automatically start the application on job submission. This means if somebody submits a job, the application auto starts, runs, and shuts back down. Pretty useful if you have dynamic jobs coming in from time to time. You can also configure your pre-initialized capacity up here. You can bump it up to maybe 10 Spark drivers and 200 Spark executors if you want. It really depends on your workload and how many folks are submitting jobs or how many machines are submitting jobs to this EMR serverless application. You can also configure the size of the driver too. So from 1 to 4 vCPUs, up to, I believe it's about 30 gigabytes of memory and 200 gigs of disk per driver or executor. So you can go ahead and configure what this default capacity looks like. Again, this is completely optional. If you want your EMR serverless job or application to just start up when a job is submitted and shut back down at the end of it, you can just disable pre-initialized capacity, and you'll only get charged for the runtime of your jobs. So I could go ahead and create an application now, but I've already done that, so let me go back to my application. That's nice and started now, so I can go in here. I can see some example jobs I've submitted before, so maybe I want to go here and look at a sample job. One of the other nice things about EMR Serverless is you can go in here and pop into the Spark history server. So when you have a completed job, I can go ahead and launch this, and this will use the logs on S3 to launch a Spark UI that you can go into and debug your job. While that's starting, I'm going to go ahead and submit a job too. Submitting a job is just as easy as creating an application. Oh, looks like my Spark history server is popping up there. Let me let that pop up. I'll go back to create a job here. So you enter your job name. I'll just call this my sample Py job. You select a runtime role with EMR Serverless. Each job that you have has an associated role with it. So that means you can run 2 different jobs at the same time with completely different access permissions. And then you put in your script location. This would typically be on S3, but I'm going to use this local py.py script that comes by default with Spark. Because of that, I get a little error message here, but that's fine. I can ignore that. You can put in script arguments if you want, and you can, of course, add additional configuration to your job. You can add Spark properties. Maybe you know exactly how many cores or memory you need, but we're just going to leave that default. You can also change some default settings on the job, like whether it uses the Glue data catalog or not, and whether it uploads logs to your own S3 bucket in addition to the Amazon EMR managed bucket. This option here enables us to use that Spark UI that we'll show in just a second. Let me go ahead and submit this job. Awesome, that job is submitted. And if I do a quick refresh here, it's scheduled and it should start running pretty quickly here. Yep, it's already running. Awesome. That is thanks to the pre-initialized capacity in EMR Serverless. And so that job actually already completed. It's a really quick one. So I can go in here and go into the Spark history server. There we go. And you can see here all the details about the Spark job as it was running, how many stages, all that kind of stuff that you might be used to looking at in the Spark UI. You can also see the event timeline here, and this shows us all the different executors that were added over the period of the job. So you can see here at the beginning of the job, it just used the default pre-initialized capacity associated with this application. As the job continued to process, it needed more capacity. So you can see all these different executors that get added by EMR Serverless. And this is scaling dynamically without you having to do anything on your side. If you want to look at logs, you can certainly do that as well in here. You just click on the Executors tab. And under here, you can see all the different logs, both for your drivers and your executors. So if I click on Standard Out for the driver here, you'll see the output of this job. This is a demo job that I have that calculates extreme weather stats for the current year, like highest temperature or wind gust. And so this is the output of that job. So you can look at the output, both of their standard error and standard out logs right in that Spark UI. So that is how to create an application and run a job in the console with EMR Serverless. It's pretty easy, right? I don't know if I clicked my mouse button any more than 5 times. Let's see what it takes to run a job in the command line interface. One thing to note while I'm talking about this, let me pull up the EMR Serverless user guide. So we've tried to do a really good job of making our documentation nice and approachable and accessible for folks that are learning about EMR Serverless. We've stepped through what you need to do to set up EMR Serverless and getting started with it, as well as how to run jobs. And we have information here about how to run jobs from the Studio console, as well as from the CLI. And even in here, when we're talking about running jobs from the CLI, we've got some sample commands there. And under Spark jobs, you can see all the different options that you can specify when you're running a Spark job. So we've tried to do a pretty good job of documenting all the different options that you can have there. And we even have a tutorial section here where if you want to run Hoodie or Apache Iceberg or Delta Lake OSS on EMR Serverless, we give you instructions on how to do that as well. And a lot of the sample code for this tutorial, like I've mentioned, is available in this EMR Serverless samples repository as well. So feel free to check that out and make use of it while you're getting up to speed with EMR Serverless. So let's go back to the command line here. In this case, I'm just going to use an EMR Serverless start job run. You can see here there's a few different things to call out. One, the application ID. So we specify the application that we want this job to run on. to the job role ARN. This is the job role that has access to the necessary resources. We specify our entry point. Again, we're just going to do this PyPy script. And we can, if we want, get more specific with our Spark executor cores and memory and all that kind of stuff. You don't need to specify these parameters, but if you have a better idea of the different resources your job needs, you can go ahead and submit them. So now that job is submitted, if I go ahead and get the job run ID and do an EMR Serverless get job run, we can see the state of that job, and we can see that it's already running. If I go back to the console and do a quick refresh here, you can see it's running right there as well. Now the other thing that we can do is we can configure these jobs to also log data to S3. So let me go ahead and update that command. And you can see here I'm going to add this configuration override section that just says for S3 monitoring, put all my logs in this S3 bucket. So I'll go ahead, hit enter there, and what I'll do, take this job run ID again, and let's do an S3 LS of that bucket. You can see here I'm specifying a full path here to applications, application ID, jobs, and I'm going to use that job run ID from right there. We'll take a look at that S3 location, and we can see there's already some data in there. This Spark logs folder, if you want to run your own Spark history server locally, you can actually do that as well and point it to this S3 bucket. Again, the Docker container for that is in the EMR Serverless samples repository. If I do another refresh of that, what we should see is now we have a Spark driver and a Spark executor location there. So let me look at that Spark driver. And inside of there, again, we have our standard error and standard out logs. These are the same logs that we saw in the Spark UI. This is a little bit of a different job. So if I do an S3 copy of that, I'm going to do a copy of my standard out just to my local machine, and I'll do a quick gun zip of that. And this job calculates an estimation of pi, so we can see the output of that job right there. So that is running your jobs via the command line. You can, of course, run jobs via the API as well. So whether that's Boto3 in Python or the Java SDK, a lot of different ways to run your jobs, including, of course, Airflow. Before we hop into the Airflow section, the other thing that I want to show is the new CloudWatch Dashboard that we just released recently. With EMR Studio, we push metrics to CloudWatch every minute. So let me go back over here, open up CloudWatch. Inside of the EMR Serverless samples repository, we've got this CloudWatch Dashboard in the CDK stack, and there's also a CloudFormation template for it too. There's a whole folder here about the EMR Serverless CloudWatch Dashboard that easily creates this dashboard for you that allows you to drill down on CPU, memory, and disk usage. We give a whole walkthrough here, including the template of how to use the dashboard, what some of the different sections mean, and what you can expect from that. But let's take a quick look at it. So here's my serverless dashboard here. And you can see, let's just do the past hour. You can see we're using 33% of our pre-initialized workers right now. So the job that we just ran used 1 driver and 3 executors, and we still have 8 available workers in that pre-initialized capacity. I haven't had to use any on-demand capacity at the moment, but tell you what, I'm going to run another job via the command line, and we should spin up some on-demand capacity. I'm going to use that extreme weather script. So let me go ahead and paste that in. That takes a few minutes to actually calculate. And what we'll see in the dashboard is that job will start running. It will start consuming all of the pre-initialized capacity, and it'll start new on-demand capacity as well. And we can keep an eye on this either for this specific application or across all of our applications using these CloudWatch metrics. We also allow you to drill down pretty deep. So we give you application metrics in terms of your entire application, how much CPU and memory and storage is allocated, as well as how many running workers you have. So this allows you to determine if you need to, tweak your pre-initialized capacity or just get a better idea of how utilized your application is. If you want to dive even deeper, we give you some of those same metrics for both your Spark drivers and your Spark executors. So if you want to see exactly how many drivers you're running throughout the day at any given point in time, you can look at that. And you can also do that for the executors as well. So pretty in-depth information here that allows you to keep an eye on your EMR serverless application and the jobs that are running on that EMR serverless application. The only other thing to show here is this pre-initialized capacity section. So we'll show how many workers you have running at any given point in time for pre-initialized capacity, as well as how many idle workers you have running. If I go back here, that other job should have started up now. So this is my CLI job with the extreme weather. And let's take a look at that Spark UI, why not? So I'll go in here, I'll click on this Spark UI. That pops open a new window. And now, here is our Spark UI. You can see if I refresh this, this is going to update in real time as this job is running, so I can see exactly how many tasks are being used, exactly what's going on with this job, and if it gets stuck somewhere or if I need to diagnose it, I can do it using this real-time Spark UI, which is really, really useful if you've got a big, long-running job and you want to be able to see what's going on with that job. Back in the CloudWatch dashboard, we should pretty soon here see some on-demand workers start to spin up. Awesome. So we can see here we're using 92% of our pre-initialized worker capacity. We're using that one Spark driver and 10 of our executors there. And then I think we had 2 drivers that were reserved. So there's still that one driver that's left over if anybody comes in and is running another job. But we can also see our on-demand capacity is starting to spike up there. So as the job is running, if it needs more capacity, it goes and requests that from EMR Serverless, and we don't really have to worry about sizing our cluster or anything like that. So pretty nice to have that there. You submit your job, it runs, things shut down. You don't really have to worry about that. All right. Now let's talk a little bit about MWAA, Amazon Managed Workflows for Apache Airflow. I'll close a couple tabs here and go back to the EMR Serverless samples repository. So in here, there is an Airflow section that has a couple sample DAGs. And if you want to use this operator directly from the serverless samples repository, you can do that by adding this line to your requirements.txt file for Airflow. Or you can install version 5.0 or greater of the Amazon provider for Apache Airflow. So this EMR Serverless operator is part of the official Airflow provider, and I'm pulling changes back in and making sure those are in sync, but you can use this either way you want to. Let's go over here and open up our Airflow console. So here's my EMR Serverless Airflow environment. I'll go ahead and open my Airflow UI. So I've pre-configured this ahead of time with a couple variables for my jobs. I'll take a look at this example EMR Serverless job here. And you can see if I look at the code, we're using a few variables that are configured in Airflow. So there's the EMR Serverless application ID, the job role, and the log bucket where we want to send logs. And all that's happening here is we've got our EMR Serverless start job operator. We're using this sample PyPy script again and logging our logs to that S3 bucket. There's a few different operators available for EMR Serverless with Airflow. And if you just Google EMR Serverless Airflow, those are available on the Apache Airflow docs. So if you scroll down here, we've got the create application operator, the start job operator, and the delete application operator. So you can build an end-to-end pipeline with Airflow and EMR Serverless. I've got an example DAG for that over here as well. So here's my example end-to-end DAG. And in here, we'll look at the graph, and you can see what it's going to do. It's going to create a Spark application in EMR Serverless, run a couple jobs, and then shut that application down. So this is completely ephemeral. When you run this, it creates the application, runs those jobs, shuts it down, and you don't have to worry about any sort of resources, and you'll only get charged for the runtime of those jobs. If we look at the code, it's fairly straightforward. We have a couple variables, again, just the job role and the log bucket. And down here, here's where we start our job. Oops, sorry, up here, we go ahead, we create the application with the specific release of EMR that we want. We start one job, we start another job, and then we delete the application once all those jobs are done. So let's go ahead and trigger this, and we'll see exactly what that looks like. While that's running, I'll also go ahead and trigger this end-to-end, or the other example job, and we can see how those jobs will run together. So if I go back to my EMR Studio console, and look at my applications, you'll see here we have 2 applications now. So this is the one that I'd created previously, and then the sample job one is the one that Airflow just created. And if I look into that one, there's no job runs there. Airflow is kind of waiting for that application to be up and running, and it only polls, I think it's every 30 or 60 seconds or something like that by default. But if we look at this job here, you can see it created the Spark app. It's waiting for that to create. Once it realizes that that Spark app is created and started, it'll go ahead and start these jobs for you automatically. So that's how you can use Airflow either to orchestrate end-to-end ETL pipelines or data pipelines using EMR Serverless, or if you just want to run a single job against an existing EMR Serverless application, you can do that as well. If I go back to the applications here, there's my old application, and this is the sample job here that got submitted from Airflow. That one's already done. If I go back to Airflow under my DAGs, you can see here that just completed and that ran successfully. And we just saw too on the example end-to-end one, it's gone ahead and it's submitted those jobs now as well. So we can view logs in here. We can see that information, the EMR Serverless job run started. If I go back to the studio and my Airflow application, we can see those jobs have been submitted there and are scheduled for that application. Now this application is not using pre-initialized capacity, so it'll take maybe a minute or two for resources to be acquired for those jobs to run. But if you've got an hour-long ETL job, that startup time is pretty negligible. When this job is done, it will go ahead and delete this application so it won't show up on your console at all. This also means you can't use that Spark history server once the job is done because the application is deleted. But in many cases, for example, a data pipeline, you'll probably be doing debugging using the Spark logs anyway. Or like I mentioned earlier, you can spin up your own Spark history server on those logs that are stored in S3. All right, so that is how to run jobs in the console, how to run jobs via the command line interface, and how to orchestrate jobs using Airflow. There's a few other things that I want to touch on really quickly. I won't show exactly how to do them, but at least point you in the right direction. So if we go back to the tutorials for EMR Serverless, oftentimes you need additional libraries for your jobs. If you're using the -- packages flag with your Spark submit command, you need to create your EMR Serverless application in a VPC. If you don't create it in a VPC, you don't have outbound internet access. You just have access to some default applications, default AWS services in your VPC. And we talk about this here in the VPC access section. Another way to do this is package up the libraries into a virtual environment if you're using PySpark jobs, for example. So in our tutorials, we've got this Python libraries section. If you just have libraries, native Python files that are part of your application, you can zip those up and put those on S3 and use the Spark submit Py files. But if you have some more complex dependencies, maybe native dependencies or something like that, you can build a virtual environment and submit that as part of your job as well. So again, we've got some example code here on how to use Docker to build a virtual environment. In this case, we're installing PyArrow and Pandas, and then creating this virtual environment using venv-pack, and then copying that up to S3. Once you do that, you can specify spark.archives and point to that virtual environment file. And then when the job starts, it'll pull down that file, unpack it, and then you have to specify the driver environment Python environment variables. So if you want to use dependencies, that's a great way to do it. By default, Amazon EMR Serverless also comes with Python 3.7.10. If you want to use a custom Python version, you can do that with a virtual environment as well. So you can go ahead, download a custom Python, build your virtual environment. It's essentially the same as using Python libraries. You just need to pack it a little bit differently, and then that's pretty much it. So you can use that custom Python environment if you want to as well. Again, this code is available out here in the EMR Serverless samples repository under examples and PySpark. And you can see there's the custom Python version one and the dependencies one. So full walkthrough in terms of how to make use of that, make use of those. And there's that extreme weather script as well if you wanted to use that too. Okay, so I think that's all I want to touch on today with EMR Serverless. So that's an overview again of how to run jobs from the console, from the command line, and orchestrate them using Airflow. We touched on the documentation and our GitHub repository. One other thing to mention, As you're going through our documentation, if you find any pieces of it that are hard to understand or even just flat out incorrect, scroll to the bottom of the page and click on this provide feedback link. Our docs team reads this every single week. I work directly with the docs team to try to make these examples as good as possible for you. So go ahead, click that, give us the feedback. We love to hear it. I hope you have a great one. Thank you.